Okay, so we're going to firstly address, so what we're trying to prove is that between any 2 points on the continuum, there exists a rational in between them, because if we can do that, then we can characterize these points on the continuum, and we can thus characterize the real numbers. Okay, so we're going to start off with an easier question, because it's going to help us work out how to do this, because this is quite difficult. So we're going to, instead of tackling that question, we're going to tackle a different question but related, that's related. Okay, so here we have 2 points. Now let's suppose they're both elements of the rational, so we'll call this P here, and this point Q, and P and Q are both elements of the rational numbers. Okay, so what we now want to prove is that if this is so, if these 2 points are elements of the rational numbers, can we prove that there's another rational number always between them, no matter what they are, as long as they're rational numbers? Can we prove that there's another rational number between them? Well, it's quite easy to prove. All we need to do is actually find this rational number in between them. And what about doing this? What about taking their average, P plus Q over 2? So this is going to be a rational number, isn't it? If P is a rational number, Q is a rational number, then P plus Q is going to be a rational number, and P plus Q divided by 2 will still be a rational number. So it's a rational number with P, and it's going to be bigger than P, isn't it? Because 2P over 2 would be P, but Q is bigger than P, so it's going to be bigger than P, and it's going to be smaller than Q, because 2Q over 2 would be equal to Q, but P is smaller than that second Q that we were going to add on here, therefore this must be smaller than Q. Okay, so it's going to be somewhere in between them, it's going to be halfway in between them, so we've found a rational that's in between these 2 rationals. Okay, so let's address another related question that's a bit harder, but is getting towards our final question. Let's suppose this is a P and this is our Q, and now let's say P is an element of the rationals, but Q is not an element of the rationals. So Q is not an element of the rationals. Okay, Vinny, shush. I'm sorry, my little dog. I'm just going to go and let him out. I'll be right back. Please, now you go. I shall go. There you go. Okay. Alright, I'm back. Okay, so Q is not an element of the rationals, so Q is some irrational number or some transcendental number. Okay, so what we now want to prove is that we can find a rational number in between these 2. Okay, so what do we know? We're going to use a little trick here. We know that on the other side of Q, there must be some rational. We'll call this rational A. So A is an element of the rationals. It's just some rational. It's just a rational that is bigger than Q. We know there must be a rational that's bigger than Q. That's a pretty... can I prove that? The rationals go on indefinitely, don't they? Because the integers go on indefinitely, and the integers are all rationals. So there must exist a rational bigger than Q. That's... yeah, there's always going to be an if Q is a number, if Q is any element of the real line, then we'll be able to find the integer that's bigger than that. That will satisfy this. It will be a rational bigger than Q. So we're just taking A, which is a rational bigger than Q. Okay, so what we're then going to do is we're going to average these 2. So we're going to take A plus P divided by 2, and we'll get another rational, because A is a rational, P is a rational, so A plus P over 2 is a rational for the same reason that P plus Q over 2 is a rational. And either this new number again will be smaller than A and bigger than P for the same reasons as this was smaller than Q but bigger than P. So there's 2 options this time. Either it will be within these, bingo, we've got what we want. It'll be within this interval here, or it'll be within this interval and we're failed. But if it's within this interval, we're guaranteed that it's smaller than A. So what do? We just take this as a new rational, A plus P over 2 here, and we average it with P. So we average P plus A plus P over 2, all divided by 2. And again, the options are it's either within this interval or it's over here. So if it's over here, obviously the drawing isn't to scale. A could be miles away and you might have to do this a long time. But the point is you'll have to do it finitely many times, and then eventually so you could get another one here, you'll average it again until you get one that's within this range, and you will always get one within that range. Eventually, if you do it for long enough, you will get one. In fact, you don't even need to do it infinitely many times. You will. This distance between here is a distance, isn't it? Between P and Q, there is some distance. It's some finite distance. So you will always, within finitely many steps, be able to find a point between P and Q.